So adjacency matrix or list. When to use what? So I made some pros and cons for every adjacency matrix or list. So let's start by matrix. For the first pro of this adjacency matrix, it performs a basic operation such as adding or removing an edge between the nodes. Also checking whether there is an edge between node 1 and 2 very efficiently and in constant time, because since we know the nodes, we can check using the 2D arrays that we have using those two nodes, and if the value is 1 there is a node, if the value is 0 there is no node between them. There is no edge between the two nodes. So this is basically for the first pro. Second pro, for the tensor graph where the number of edges are large, the adjacency matrix is really suitable for this one, because in big O terms, which is big O notation, they don't take up more space because the space already exists. We're not going to use any extra space other than the 2D array. And the operations are much faster because they run in O form. And maximum number of cells of the matrix are filled because of more number of edges. So basically, it is very space efficient because we already have the values inserted, whether it was 0 or 1, so we're not going to use any extra space. But if the graph is sparse, in that case most of cells are vacant. That means we're not using the information that there is an edge between the nodes, so it's kind of pointless to have it. So this is kind of waste of more space. So I can't really say it's a consequence. It's kind of pro because for the tensor graph it's a pro, but for the sparse graph that's not really the best option to use. Now for the first consequences of adjacency matrix. The most notable advantage is the space complexity, because we're using V times V, where V is the number of vertices, and in real life scenario we don't have so dense connection, so many edges will be used so the space mostly get wasted. And therefore if you're gonna use a sparse graph with less number of edges, that means adjacency lists are always preferred in that case. That's the first consequence. For the second consequence, some operations such as in edges, whether to check whether there is an edge directing towards this node, and out edge to check whether there is an edge directing out from this node, are expensive in adjacency matrix because you're gonna be iterating through large number of space in that 2D arrays, because it results from V times V. So this is kind of expensive operation when you're talking about in edge and out edge in adjacency matrix.